She looks like nothing else in the fleet. Sharp, angular, silent. A 16,000-ton destroyer that appears on enemy radar as a small fishing boat. The USS Zumwalt was built to end wars before they started. She was the most expensive surface combatant in American history, and her missions have been unlike any warship ever launched. From a humiliating breakdown in the Panama Canal, to a silent ghost patrol through contested Pacific waters, to a shocking resurrection as the Navy's first hypersonic strike platform. This is not a story of guns firing. This is a story of a ship rewriting itself in real time. Every mission of the USS Zumwalt. The date is December 7, 2015. Location: the Kennebec River in Maine. 1,200 feet of black glass hull, sliding out of the Bath Iron Works basin into open Atlantic water for the first time. She weighs almost 16,000 tons, twice the size of an Arleigh Burke destroyer, and she looks nothing like one. There is no bulbous bow, no traditional superstructure. Instead, a tumble-home hull that slopes inward, a composite deckhouse that hides every sensor, an integrated power system that can push 78 megawatts, enough electricity to run a small city. The tumble-home hull is the defining physical feature. Unlike a normal warship that flares outward above the waterline, Zumwalt's sides slope inward as they rise. This shape scatters radar energy downward away from the emitter. The composite deckhouse above absorbs the rest. Together, they collapse the ship's radar cross-section by a factor of 50 compared to a conventional destroyer. The sea trials are called Alpha Trials. Bath Iron Works engineers are on board. Navy inspectors ride alongside. The turbines light off. Twin Rolls-Royce MT-30 gas turbines. 2 auxiliary Rolls-Royce R4505s. Combined electrical output. Combined shaft output. It all runs through a single integrated power grid. The first time any American warship has done this at full scale. She pushes to 30+ knots. Handles like a much smaller ship. The rudder response is crisp. The wake pattern is unusually flat. The engineers watch the sensor logs in real time. Vibration signatures are lower than modeled. Acoustic emissions are dampened. Her wake looks stealthy. When she returns to port after 4 days of trials, one lead engineer describes her simply. She breathes. She listens. She hides. The Navy accepts delivery in May. But this is only the beginning of a very strange life. Where do you take a warship that no radar can see clearly? Straight into a canal. And straight into humiliation. The date is November 20th, 2016. Zumwalt has been commissioned less than a month. She departs Norfolk, Virginia, heading south. Her destination is San Diego, her home port. To get there, she must transit the Panama Canal. It is her first strategic movement as a commissioned warship. The world is watching. Navy Public Affairs has released photos. Panamanian media are camped along the locks. And halfway through the canal, on November 22nd, everything goes wrong. The USS Zumwalt integrates a small set of headline systems that define her value. The Advanced Gun System, 2 barrels forward, was designed to hurl guided projectiles 80 nautical miles inland. The total ship computing environment runs every subsystem through a single fiber network. The peripheral vertical launch system holds 80 missile cells around the deck edge, doubling as armor. The integrated power system feeds all of them from one shared electrical grid. And the composite deckhouse hides every antenna behind a single stealth shape. The bearing seals in the port shaft propulsion system fail. Seawater intrudes into the lube oil sump. The bearings begin to grind. The crew catches the temperature spike within minutes. Emergency shutdown of the port shaft. But now Zumwalt is trapped inside the Miraflores locks, on a single shaft. In one of the narrowest, most trafficked waterways on Earth. She cannot maneuver freely. She cannot hold station against the canal current. Panama Canal Authority tugs are called immediately. 2 workboats latch on. They begin the slow tow. She creeps into the Rodman anchorage, just outside the canal's Pacific exit. There she sits. Silent. Dead in the water. For 12 days. The optics are brutal. Photographers capture her at anchor. A $4 billion warship. Held on station by 2 dockyard tugs. Navy engineers fly in from Washington. Bath Iron Works sends a flyaway repair team. They pull the bearing housing. Confirm the seal failure. Machine replacement parts on site. It is not a design flaw. It is a first-of-class shakedown reality. But the internet does not know that. Aims go global. She is the ghost that could not sail. When she finally limps into San Diego weeks later, The Navy quietly reframes the incident as a learning event, but the crew knows. This was Zumwalt's baptism, and it was not glory. A ship this stealthy cannot even cross a canal. How do you prove she can hide in an ocean? The date is early 2017. Location: the Southern California operating area off San Clemente Island. The Navy needs to know a number. A specific number. How small does Zumwalt look on radar? The engineering models say she should appear roughly the size of a small commercial fishing vessel, about 50 feet long, displacing under 100 tons. But models are models. Reality is reality. So the Navy sets up a controlled radar cross-section test. Radar cross-section is not a physical size. It is an equivalent size. B-2 bomber, 69 feet wide, returns radar energy roughly equal to a marble. Zumwalt is 600 feet long, but her hull geometry, radar-absorbent coatings, and composite deckhouse are designed to make her return signal collapse to that of a small trawler. The hostile air search radars, she should vanish inside civilian sea clutter. The range instrumentation ship parks 15 nautical miles offset. Zumwalt runs a series of headings: bow on, beam on, quarter on, stern on, every aspect angle. The instrumentation ship logs return strength. In parallel, Navy tactical aircraft from Naval Air Station North Island fly overhead search patterns. Their radars sweep the ocean multiple times. On several passes, they do not resolve Zumwalt at all. On others, she appears as a distant, low-return contact. The tactical pilots later describe it plainly. They see a fishing boat where a destroyer should be. Then comes the confusion phase. Zillion fishing vessels operating in the same area begin appearing on the same tactical picture. Zumwalt is indistinguishable from them. To an incoming missile seeker, this matters enormously. Modern anti-ship missiles use their own onboard radar in terminal phase. They pick the largest return in their search cone. If Zumwalt looks like a fishing boat, and there are real fishing boats nearby, the missile cannot be sure. It may pick the wrong target. It may lock onto clutter. It may miss entirely. Tests confirm it. She is not invisible, but she is deniable. In a crowded coastal environment, that is more valuable than invisibility. But what good is a ghost with no bullets? The date is 2018, and Zumwalt has a problem she cannot hide. Two massive 155mm advanced gun systems mounted on her bow are the largest naval guns installed on an American ship since the Iowa-class battleships. They were designed to fire the long-range land attack projectile, a guided rocket-boosted round that could hit targets 80 nautical miles inland from over the horizon. Silently. Precisely. In practice, though, only 3 ships of the Zumwalt class were ever built. The projected buy of 32 hulls collapsed. The unit cost of the projectile skyrocketed. Each round would have cost the Navy roughly $800,000, more than a Tomahawk cruise missile. The advanced gun system is not a conventional naval gun. Each turret houses a fully automated magazine holding 300 rounds. The hydraulic loader cycles projectiles from magazine to breech. A separate propellant charge canister accompanies each round. The guided projectile itself, the LRLAP, is a rocket-assisted glide round with a canard control section and an inertial and GPS guidance package. The whole system was purpose-built for over-the-horizon precision land attack from a stealth ship. The Navy cancels the projectile program in 2016. Now Zumwalt sits with 2 massive guns and no ammunition for them. The turrets are physically operational. They can slew. They can elevate. They can cycle. They just have nothing to shoot. For years, the guns remain quiet. In tactical exercises, Zumwalt sails with the largest naval artillery in the fleet, loaded, in effect, with air. Analysts call it the most expensive naval saluting cannon in history. The crew trains around the void. They rely on Zumwalt's other systems: her stealth, her sensors, her missile cells, her networked computing environment. The Navy studies replacement rounds. They test hypervelocity projectiles borrowed from railgun research. They evaluate off-the-shelf artillery rounds. Nothing fits cost or performance requirements. The silent gun becomes a symbol, a reminder that stealth means nothing without a weapon in the tube. But what if you did not need a gun at all? What if the tubes themselves became the weapon? The date is late 2019. Zumwalt is finally forward deployed. She departs San Diego for her first extended Pacific Presence patrol. She sails west, past Hawaii, into the western Pacific, toward waters watched closely by China and North Korea. The mission is straightforward on paper. Show presence. Test her systems in a realistic operational theater. Integrate with 7th Fleet. But the Navy is watching something else. How does a stealth destroyer signal deterrence when the entire point of her design is to not be seen? Presence patrols work through visibility. The carrier strike group is meant to be photographed. Its position is meant to be known. It is a message. Zumwalt's design inverts this logic. She can be present without being seen. She can be seen without being tracked. Adversary intelligence services must ask a harder question. Is she nearby? And if she is, where exactly? That ambiguity is itself a deterrent. Zumwalt operates in the East China Sea window. She transits the Miyako Strait. She rendezvous with Japanese Maritime Self-Defense Force destroyers. She conducts combined maneuvering drills. Chinese surveillance aircraft attempt to shadow her. On multiple occasions they lose contact. Not because she disappears, but because in the crowded shipping lanes of the East China Sea she looks like traffic. Her AIS transponder is often off. Her radar emissions are muted. Her communications are minimal. She becomes a moving question mark on the adversary's tactical picture. She surfaces for port visits. Yokosuka, Japan. Guam. And she vanishes back into open water. For weeks at a time, only her chain of command knows exactly where she is. For a fleet that historically trades on presence, this is a new kind of tool. Presence by absence. Deterrence by uncertainty. She returns to San Diego in 2020. Logbooks full. Ammunition largely unused. Doctrine quietly being rewritten. The Navy has now confirmed what she can do. The next question is what she is for. Because the biggest change in her career is not going to come at sea. It is going to come in a shipyard. The date is August 2023. Zumwalt enters the Huntington Ingalls Industries shipyard in Pascagoula, Mississippi. 2 advanced gun systems on her forward deck are cut out, physically removed. In their place, the shipyard installs 4 large-diameter missile tubes. Each tube can house 3 conventional prompt strike missiles. 12 rounds total per ship. This is the Navy's hypersonic weapon program. Boost glide vehicle capable of Mach 5+. Fired from a common all-up round shared with the Army's Dark Eagle system. The conventional prompt strike weapon is a 2-stage rocket boosting a common hypersonic glide body. The glide body separates at high altitude and flies at hypersonic speed within the atmosphere. It maneuvers unpredictably. It cannot be intercepted by any existing air defense system. Fired from Zumwalt, it can strike hardened targets over 1,700 miles away in under 15 minutes, from a ship that adversary radar cannot reliably locate. The conversion takes over a year. Every element is bespoke. Larger missile tubes require larger openings in the forward deck. The magazine cooling, ventilation, and safety systems are rebuilt. The total ship computing environment is patched to control a new weapon it was never originally designed for. Fiber optic runs are rerouted. New antenna cutouts are added. New fire control loops are integrated. Naval Sea Systems command engineers work alongside Ingalls shipwrights and Missile Defense Agency specialists. The ship's own crew rotates through Pascagoula, training on systems that do not yet exist elsewhere in the fleet. What was once the most controversial naval gun program in American history is being replaced with the most anticipated strike weapon of the 21st century. When Zumwalt sails again, she will be a completely different warship than the one that broke down in Panama 7 years earlier. She will be the first American surface ship to carry hypersonics operationally. And then Ghost will finally have a blade. But what happens the first time that blade actually swings? The date is late 2025. Zumwalt is at sea. Location: an instrumented range in the Eastern Pacific. She is preparing for her first live end-to-end test of the conventional prompt strike system. This is not a static test firing. This is a full mission cycle. Tasking is transmitted from a shore command element. Zumwalt's crew receives target coordinates. Time on target. Restricted flight profile. The onboard fire control system builds a launch solution. The all-up round is armed. The forward deck opens, and the launch sequence begins. A hypersonic boost glide missile does not fly a ballistic arc. A 2-stage booster carries the glide body to the edge of space in roughly 90 seconds. There, the glide body separates. It re-enters at hypersonic velocity. It flies inside the atmosphere at Mach 5 to Mach 10. It can pull lateral maneuvers of many G. This flight profile is not tracked well by traditional missile warning radars, and it cannot be intercepted by any operational air defense system today. The first stage motor ignites. The missile clears the deck. The plume is enormous. Briefly whites out the ship's forward camera feeds. Zumwalt heals slightly under the launch reaction. She recovers. The missile arcs upward, into the mesosphere. Telemetry streams to instrumentation aircraft overhead. The glide body separates. It re-enters. Maneuvers. Then it impacts an instrumented target site downrange within the designated impact box. The circular error is measured in meters. The flight time is measured in single-digit minutes. Analysts at Naval Surface Warfare Center Dahlgren pore over the telemetry for weeks. The system works. From ship to target. End to end. In one launch, Zumwalt goes from a broken experiment to a strategic asset. She can now hold targets at risk that no other surface ship in the fleet can hold. She can do it from stealth. She can do it in minutes. She is no longer the ship that could not cross a canal. She is the ship that can strike a continent away. So what does she do next? Zumwalt was born as a controversial experiment. Too expensive. Too different. Too early. But her real value was never the guns. It was the platform. The silent, all-electric, high-power hull that the Navy could rewrite around new weapons for decades. Today, she carries hypersonics. Tomorrow, she may carry lasers, or directed energy defenses, or unmanned command nodes. Every one of her missions has been a lesson, and every lesson has bent the future of surface warfare. If you want the next deep dive into the ships and weapons rewriting modern combat, subscribe, like this video, and tell us in the comments which mission surprised you most. The USS Zumwalt is still writing her story, and the next chapter is only just beginning.